In section 5.5, we're going to study the area of trapezoids, and our learning goal for this section is that students will understand how to calculate the area of trapezoids and composite figures. The success criteria that we have for this section is I can identify the legs, bases, and altitude or height of a trapezoid. I can find the area of a trapezoid using a formula. I can use the properties of the special right triangles that we studied, as well as the Pythagorean theorem in problems where I need to find the area of trapezoids. And I can use area formulas to calculate the areas of complex composite figures. So let's begin. Let's first start by talking about the different parts of a trapezoid. The bases are always, always, always parallel. The legs are the two sides that are not parallel. Remember, in a definition of a trapezoid is a quadrilateral that has exactly one set of parallel sides. Those parallel sides are called the bases. So in this figure on the left, this would be a base, and this would also be a base. Then the other two sides would be legs, and then the height is perpendicular to the bases. So the height would come straight down like this and form a 90-degree angle. You might draw the height there. You could move it. The height could be here. You could move it over here like that. The height could be there. That's the height. And sometimes the height we also call the altitude of a triangle. Just like altitude means how high you are up in the sky, here altitude means how high the base is, somewhere like that. Okay. In the second picture we see, again, we have base. So I might call that B1 for the first base and B2 for the second base. That helps me distinguish between the two bases. The legs are still the two sides that are attached to the bases, and the height still connects the bases and forms a right angle. Now the area formula for a trapezoid is a little bit complex. It kind of looks like the area formula for a triangle. Remember that was area equals 1/2 the base times the height. So it looks a lot like that, except for instead of multiplying 1/2 times the base times the height, we're going to multiply 1/2 times the height times the sum of the two bases. So we have to add those two bases together, then multiply by the height, and then multiply by 1/2. Or another form is we could add those two bases together, B1 plus B2, multiply that by the height, and then divide that by 2. Because remember, dividing by 2 is the same as multiplying by 1/2. So let's use that formula in a problem. Let's find the area of the trapezoid that we see here. So I went ahead and copied that area formula so we'd have it as a reference. And so we can see that in this particular problem, maybe the first base is 8, and the second base is 12, and 6 would be the height of that trapezoid. So let's plug all those values into my area formula. Area would equal 1/2 times the height in this case, which is 6, times the sum of the bases, 8 plus 12. And remember, our order of operations say I have to do what's inside the parentheses first. So first I'm going to add 8 plus 12 and get 20. Now here I have some choices, because really what's going on here is all multiplication. 1/2 times 6 times 20. I could, if I wanted to, multiply 6 times 20 together first, but that's a big number. So let's not do that. Instead, let's multiply 1/2 times 6 together first. So 1/2 of 6 is 3. So now my problem becomes 3 times 20. And 3 times 20 is 60. Now let's go back to our units. They were centimeters. This is area. So my area would be 60 square centimeters. All right, so let's kick it up a notch and do a problem that requires a couple more steps. Let's find the area of this trapezoid. Inspecting this figure, I can see, well, I have one of the bases here, but I don't seem to have the other base. I don't have a measure for it, but I do see some information that tells me that this angle here is 45 degrees. So what I'm going to do is draw in another height and create a 45, 45, 90 triangle. Now I'm going to use, maybe I'm going to use, there we go. Now I'm going to use the properties that we talked about with 45, 45, 90 triangles to help me figure out a couple sides that we see here. I'm going to use that information to help me find this side and this side. One of those is the height. The other one is going to help me find the base, the second base of that trapezoid. So remember, if I've been given the hypotenuse is always the leg times the square root of 2. So if I've been given the hypotenuse, if this is 4 root 3, then I need to figure out, well, what would x be if that was equal to x root 2? Okay, so what we're going to do is we're going to say, start with our formula. The hypotenuse is equal to the leg times the square root of 2. In this case, my hypotenuse is 4 times the square root of 3, and my leg is, I don't know, let's call it x for right now, like we have in the picture. So x times the square root of 2. So if I want to solve for x, I have to divide both sides by the square root of 2. All right, so x is equal to 4 square root 3 divided by the square root of 2. Now, I usually don't like to leave my answer like that, so we're going to rationalize that. And so root 2 is the root on the bottom, so I'm going to multiply by root 2 over root 2. So on the top we have 4 times the square root of 3 times 2, which is 6. On the bottom, root 2 times root 2 is the square root of 4, but the square root of 4 is 2. And then now notice we can actually reduce 4 divided by 2 is 2, so this becomes 2 root 6. So let's go ahead and fill that in on my picture. Now I know the height is equal to 2 root 6, and I know this piece of my base is also equal to 2 root 6. Now for the rest of the base, remember this part up here was 3 units. That means this part down here must be 3 units. So we can represent the entire base as the sum of those two values. 2 root 6 plus 3 is the entire base. Okay, so now let's take all of that information and plug it into our area formula so we can find the area of this trapezoid. Okay, so area is equal to 1/2 the height. The height, remember, was 2 times the square root of 6 times the sum of the bases. Now the first base was 3. And the second base was 2 root 6 plus 3. So now we have to simplify this. First, let's do what's in the parentheses. So what's in the parentheses is 3 plus 2 root 6 plus 3. So combining like terms, I can add 3 plus 3 together and get 6. So really, the only thing I can do here is make this 6 plus 2 root 6. Now, outside the parentheses, we can multiply 1/2 times 2 root 6. So think about that as 2 over 1. 1/2 times 2 over 1 is 1. So this becomes 1 root 6. So really, we have root 6 times 6 plus 2 root 6, and we can distribute. 6 times root 6 is 6 root 6, and root 6 times 2 root 6. So that's going to be 2 times root 6 when I distribute that. I wrote this out for a reason. Root 6 times root 6 is the square root of 36, but the square root of 36 is 6. We want to multiply that by 2, and then we're going to add 6 root 6. So finally, simplified, my answer would be 6 root 6 plus 12. And in this case, I didn't give any units, so we would write square units. Whew, that was a tricky problem. All right, let's kick it up one more notch. Let's find the area of this trapezoid. So here, same process. We know that this side over here is 4 root 3. I'm actually going to change that just to make this problem just a little tiny bit. Well, no, I'm gonna leave it. We're going to leave that 4 root 3 because then we can use the information from the last problem. Okay, so remember, we had this base up here was 3, so that's base 1. We do not yet know base 2, but based on the last problem, we do know that this height is 2 root 6. So we know that this piece is also 2 root 6. Okay, now we know this much here is 3, but we do not yet know this piece right here. And that's the piece that we need, right? Because we have to find that in order to be able to calculate the entire base. But since this height here was 2 root 6, that means this height, the other height is also 2 root 6. So this piece here is 2 root 6. So essentially what we have is a 30, 60, 90 triangle, right? We see that 60 degrees in there. I'm going to just flip this. So, whoops. Maybe I won't flip it. But what we have is the height, 2 root 6. We have a 60-degree angle. And what we want is that little piece right there. Because that's across from the 60 degrees, that has to be the long leg. And this has to be the short leg. So let's start with our formula. The long leg is equal to the short leg times the square root of 3. So the long leg is 2 root 6. Let's plug in that information. And the short leg is x. So if x times root 3 is equal to 2 root 6, to undo multiplication, we divide both sides by root 3. So x is going to equal 2 times the square root of 6 divided by the square root of 3. Now remember, we can make that division all live under one root. So we can make that the square root of 6 divided by 3. But 6 divided by 3 is 2. So this just becomes 2 root 2. So this little piece here is 2 root 2. That means the entire base is 3 plus 2 root 6 plus 2 root 2. That's the length of my entire base. So now let's take that information and plug it into my area formula. My area is going to equal 1/2 times the height, which was 2 root 6, times the sum of the bases, 3 for base 1, 3 plus 2 root 6 plus 2 root 2 for base 2. All right, inside the parentheses, I can again only combine 3 plus 3, so that gives me 6. The other two expressions I can't add together because they have different numbers under the root. Right? Here we have root 6, here we have root 2. We can't add those together. However, over here, again, 1/2 times 2 root 6 is just root 6. But if we want to distribute this through, root 6 times 6 is 6 root 6. Root 6 times 2 root 6, remember what that was? Root 6 times root 6 is the square root of 36, which is 6. And 6 times 2 is 12. Now we can distribute it to the last term. Root 6 times 2 root 2. So root 6 times root 2 is root 12. So this becomes 2 root 12. Now I got to be real careful of that root 12 because I think I can simplify him. That's 3 times 4, and 4 is 2 times 2, so I have a pair of 2's with a 3 left over. That's actually equal to 2 root 3. So this becomes 2, this 2, times 2 root 3, which is equivalent to the square root of 12. So multiplying that together gives me 4 root 3. So my entire expression for the area of this trapezoid is 6 root 6 plus 12 plus 4 times the square root of 3. Might be helpful to get a decimal approximation because I really have no idea about how big that number is. All right, let's do the next one. Let's find the area of a trapezoid that's bounded by these lines. X equals 2, x equals 5, y equals 1, and y equals x plus 1. So let's remember, when I have x equals a number, that always results in a vertical line because the x-coordinate stays the same everywhere. So this red line right here would be the line x equals 2. Then the line x equals 5 would be where the x-coordinate is 5. So that's this line here. The line y equals 1, again, is a straight line, but this time it's horizontal. So y equals 1 would be where the y-coordinate is 1. So that looks like this. Now lastly, we want to graph the line y equals x plus 1. So this is in slope-intercept form. The intercept is positive 1, right here, and the slope is 1. So we'd go up 1 over 1 to plot more points on the graph. So let's fill in that line. Looks like my line does something like this. Also looks like I might need to extend my red line just a little bit. There we go. Okay, so do we see a trapezoid enclosed by these lines? I hope you guys can see it. It's here. And in this case, my bases are actually running vertically. But let's look and see if we can't find the height and the bases. So if I start on the left, this base here is 2 units. And this base here is 1, 2, 3, 4, 5 units. So we'll call that base 2 and base 1. Now remember, the height is perpendicular. So in this case, the height actually ends up being a side of the trapezoid, and it is 3 units. I don't even need to know anything about this slanty side that was created by that other line. So area is equal to 1/2 the height times the sum of the bases. So in this case, that's going to be 1/2. The height was 3, and the two bases were 2 and 5. So simplifying that, it's going to give me 1/2 times 3 times 7. And let's see, that's going to give me 3 times 7 is 21. And half of 21 is 10.5. So the area here is about 10.5 square units. Now, interestingly, by the way, if you just look at this, you can kind of see that that makes sense. Right here, that's 1 square box, so 1 square unit, 2 square units, 3 square units, 4, 5, 6 square units, 7, 8, 9 square units. So we have 9 full squares in the box. 2 more half of a squares would make 10 square units, and then you can see we have 1 more half a square, so 10.5 square units. Okay, one final example to look at. Let's say Joe knows the following information about a trapezoid. He knows that the area is 14 square centimeters. He knows that one of the bases is 5 centimeters, but the other base he doesn't know. And he also knows the height is 2 centimeters. We want to identify which equation Joe could write to find the unknown base, B2, for the trapezoid. So which one of these equations could actually represent the length of the second base? Well, what we're going to do is we're going to start with that area formula. Area equals 1/2 the height times the sum of the bases. And what we want to do is isolate this variable B2. So the first thing I want to do is get rid of that fraction. It might also be helpful if you want to. You can think about that area formula. I'm going to go down to the bottom of the page here so we have lots more room. To think about that area formula in the second way we wrote it, B1 plus B2 over 2. Now remember, that fraction bar is a grouping symbol. So the first thing that we have to undo here is that division. But we undo division with multiplication. So we can we can multiply both sides by 2. So 2 divided by 2 is 1. So over here we have 2a equals the height times the sum of the bases. Now again, we have a grouping symbol. So before I can undo anything in that grouping symbol, I have to undo what's on the outside of that grouping symbol, which is multiplication. So we'll undo that multiplication using division. H divided by h is 1. So on the left, that leaves me with 2a divided by h. And on the right, we'll have b1 plus b2. We're almost done. Remember, we're trying to solve for the second base. So we have addition. So we'll undo it with subtraction. So 2a over h minus b1 is equal to b2. So let's see if we see this expression as any of the answer choices. 2a over h minus b1. So there it is. So it looks like A is the correct answer. It was much easier to work this problem forwards than it was to try to look at the answer choices and select which one of them was correct just by looking at the answer choices. So there you go. What I'd like you guys to do now, go in and fill in any left-hand column questions that I had written down, any others that you think are important, and complete your summary.